Okay. We can start, right?
Yes, please.
All right. Thank you. So, good evening once again, everyone. Apologies for this beyond. Hopefully today, I hope the network cooperates so that I can just quickly do this class. So, today we will just I'll be introducing us to OOP, which stands for Object-Oriented Programming. So today's class will be an introduction to OOP. We have basic principles of OOP. We have like 4 of them, right? Before the end of today, I will only introduce 1 of them. Then also, today's class will be a bit more of talking, then less code. But this concept is very, very important. And if we get this right, then it's going to make our C# programming journey very, very easy, right? It's a concept that is a bit tricky, but at the same time, it's simple. And I will try my Hello, can you hear me?
Yes, please.
Hello?
Yes, I can hear you.
All right, thank you. So object-oriented programming means you are trying to when you code, right, to an extent it looks abstract, right? But in object-oriented programming, what we are trying to do is we are trying to relate real life objects, right? Real life scenario or real life object or real life scenario to programming such that it will be relatable, right? And some of the benefits of object-oriented programming is that it is fast and easier to execute, right? Then is clear structure for the programming. That is, you can relate with it and you can properly structure your code base such that it is easier for you to maintain, right? Then OOP helps to keep the C# code dry. What we mean by dry means don't repeat yourself. The reason for that is that if you have, for example, an implementation in your code that you repeat across board, anytime you need to make change to that implementation, that will require you making change to every instances where you have that code in your code base. And that will make maintaining of your code difficult because at times when you develop a software or where you work, there might be instances where you won't be the one maintaining the code or the application you built, right? So you should be considerate such that any person that will be introduced to your code base should find it easy to understand. It should be easier for the person to understand, and as well, it should be easy for him or her to also maintain. So that once you make a change, for example, a bit of code that is being reused across board, once you make a change in that code, it should easily reflect across board. So that is why we say, don't repeat yourself, right? It makes the code easy to maintain and also modify. Then OOP makes it possible to create full reusable application with less code and shorter development time, right? Those are just the I sum up advantage of OOP, right? Which makes it in vogue now compared to other programming pattern programming pattern, which is a procedural programming or functional programming. So now let's dive into it a bit. Classes and objects are the two main aspects of object-oriented programming. That is, once you hear the word object-oriented programming, that means you have a class and also you have objects. Okay, so C# is strictly an OOP, right? That's why for every C# you have a startup class. I mean, a startup method with main method, which is the startup method, right? Or the startup method is always in a class, right? It's always in a class. So let me just quickly say this. You might be building maybe your future project or whatever in .NET 6. In .NET 6, you might see just a function directly without it embedded in the class. So that process has been a bit refactored in .NET 6. But to the main background of it, whenever you see any method in C#, it's always in a class. Like this method now, for this class, I'll be making use of this program class and also this main method, which will be the start point for our program, right? I'm sure you'll have seen something like that in most of the materials that you've read. Everything in C# is associated with classes and objects, along with its attributes and method. So when you hear the word class, what are the things that we see in a class? Basically, a class is made up of attributes, which we can also refer to as its fields or properties. We can refer to them as fields or properties, and also it's made up of methods, okay, which we call functions, or some people call it routines, okay? So we'll be looking at this as we go along in the class, in this session. So for example, in real life, a car is an object, right? The car has attributes such as weight and color, and methods such as drive and brake, right? So just as I rightly said, so a car is an object. If you are modeling a car, for example, in your program, you need to put in some attributes, which is the weight, the color, and some other attributes that a car has. So we can refer to them as the fields or the properties of a class. Then the method, which is what the car does, okay? Like drive, right? And also brake. So we can refer to methods of the class as the actions that object does, right? For example, when you are modeling the class, okay? The class can have properties, features, right? It can have properties, right? While the actions, that is what the car can, we can refer to those properties as the state of that class. And also what the class does, we can refer to them, the action words, they are the methods, the functions that the class can be made up of. So a class is like an object constructor or a blueprint for creating objects. A class is like an object constructor or a blueprint for creating objects. So I'm making emphasis on this because we need to understand this concept so that it will guide us through through our programming journey. Okay, so when we refer to something as a constructor, all right, so that constructor is not the object. There's difference between the object and the constructor. okay, take for example, I know, please you can respond. How many of us are familiar with a block industry? Or how many of us has been to a block industry before? Right? I believe some of us are familiar with the block industry or have seen where people are making block. All right. So let's use a manual one as an example. Right. I don't really know the name of the object now, but you know there's an iron that they use in molding block. I can't remember the name now. Right. But you notice that that iron, they will fill it with sand that has been mixed with cement. Right? You know, that single iron now can produce as many as possible blocks. You get that concept? So in this case now, the class is that iron that is used in molding block. Why the blocks that are being molded are the objects, right? So the class that are being, the blocks that are being molded, they are the objects that are being produced by the class. So the class is just a template, is a blueprint for creating objects. Another common example is a cookie cutter or this iron that is it iron pan that is used in making bread, right? You notice that one of that iron can make thousands of bread. So the bread itself is the object, while the iron that we use in molding the bread, those shape, whatever shape or price that, or whatever shape that the object, that the bread that is being molded from, okay? So whatever shape that is being molded from, that shape that mold that bread is the class. Okay, I don't know if we are getting what I'm saying, right? Please, if you have any questions so far, you can ask, or if there's any point I've made that you need clarity, you can just ask before we move on. Hello, are you guys with me?
Yes, we are with you.
Okay, so the points I've made so far, you all understood, right? Please, if you don't understand at any point, just feel free to talk so that I can explain it over again. So classes and objects. Everything in C#, okay, I think I've read through this. So an object is created from a class. That's what I just explained earlier. We have already created the class name car, for example. So we can use this to create objects. So to create a class, we use the class keyword. Whenever you want to create a class in C#, we use the class keyword. All right. We use the class keyword. So we'll be looking at an example soonest. So to create an object of car, specify the class name followed by the object name and use the keyword new. That is, when you now want to create the instance of the class, you use the new keyword to create the instance of that class. So a class is a template for objects, and an object is an instance of a class. So once an instance of a class is being created, by default, that the instance of that class takes the properties. It has it inherits the inbuilt properties and functions of that class. So when the individual objects are created, they inherit all the variables and methods from that class. So let's look at this for example. We are just make things faster. So for example, this is a simple class called car. All right. Whenever you are creating a class, right? In C#, you use the keyword class, all right, followed by the name of that class. For example, the name of our class now is car. So another thing you need to note here is that the first, when you are creating a class, we make use of Pascal. We make use of Pascal model, right? We make use of a Pascal naming model. What I mean by Pascal naming model is that every first letter of the words are in capital letter. For example, this one, car, you can see the first letter is in capital letter, right? So now this is a car. For example, the brand name is equals to Mercedes-Benz, for example. Then the model, let's say the model is equals to 2019. So these two now, they are the fields of that class, right? These two are the fields of the class. Then we have public void display. So this, I believe you've been taught how to create a method in C#, right? So this public void display now is a function. It's a function or routine or what that class can do, right? So we have public void display name. All right. So this is a simple class in C#. So we have the properties and we also have a function in that class. So what this function is basically doing is that it's just writing to the console, right? It's writing to the console the brand, the name of the class. We're just writing to the console the name of the class. So now let's use it in code now. So we have car. So you can see now what I'm doing here is that I'm creating the instance. Okay, I'm creating an instance of this class. That's what I've done here. I've created an instance of this class. All right. So, and I can create as many as possible instances of this class because this class is just a template. So I can use it to create many objects of this car class, right? So this is just an instance of the class. So, and what I'm doing now after is that I'm accessing a method in that class. So how do you access a method or field? How do you access a method or public field of the class? You use the dot sign, right? You use the dot sign to access it. So after creating the instance of the class, I use a dot sign. You can use a dot sign to access every properties, every public properties that are in that class. So if we run this now, you notice, let me just quickly run this in a terminal. Running. Okay, wait, I think I need to navigate to this. I'm sorry, just a moment.
You're already on line 102. Just click on or just press F10 to go to the next line.
So I noticed it's not displaying it on the console. That's
Yeah, I think it's because you're debugging, so you're going to be seeing it here in the debug section.
Yeah.
So right now you're on line 102. So press F10.
Okay, I'm not seeing this. Okay. I'm not seeing it.
Yeah.
So yeah, we can see.
Okay, so it has
We
printed
can
now.
see that the method, that method in that class, right, has been implemented. And what we have in that method is just displaying the method is just displaying the name, right? It's just displaying the name of that car instance. So we don't need to do anything. What you notice is that we don't need to do anything, much things in our code. What we are just doing is that we created the instance of that class, and also we call the function of that class, and the function just runs like that. Okay, so that is one good thing about object-oriented programming, right? You can easily decide, you put every properties and decide what you want to do within that class. And you can also reuse it. So I can reuse this anywhere in my code, as long as I make reference to the class itself, right? I can easily just call this method anywhere, all right? And if I now want to make changes to the method, right, I just need, let's say I have 10 instances of this my car, right, of this car class. If I want to make change now to this method, what I just need to do is just to come to this class and make my changes here and there. And the changes will be effected in every place in my code that I make use of the instance of this class. So that's one of the good and very interesting thing about OOP, right? So let's just let's continue. Okay, so you can also leave the first field blank and modify them when creating the object. So we're going to look into that later. So it's not always compulsory to assign the fields, assign values to the field of the class when creating the instances. Okay, you can assign to them at any point in time. You can decide to make this public. We'll still talk about what identifier is, all right? We'll still discuss that. So you can decide to leave these fields blank till when you now want to assign to it at any point in time when you are working with your application, all right? So yeah, we'll learn more from this later. So methods normally belong to a class and they define how an object of a class behaves, right? As I said the other time, properties is just the state of that class, and the method is the character or function or behavior of that class. That's what we refer to as method. So just like sheets, you can access methods with the dot syntax. I think I've said that earlier. However, note that the method must be public. So we'll discuss what public is, what private is, internal, and the rest later in this session. And remember that we use the name of the method followed by parentheses, right? You know, that's how to create a method in C#. You write the method name, the return type. Let me just quickly explain that here. So for example, this is a method, right? You know, I'm declaring it as public so that wherever we want to use the instance of this class, of this car class, anyway I'm using the instance of this car class, this method can be accessed. So we want it to be accessed. That's why I declare it as public. Then this is the return type. When we see void, that means it's not returning. That means the method is not returning anything. All right. So, and if the method needs to return any type, you put the type that you want the method to return here. Maybe you want it to return a type class that you've modeled yourself, or you want it to return an integer, you want it to return an array, you want it to return string, whatever. You just put the type here, then followed by the method and also parentheses. All right. So for methods, you can, this is, for example, this is a parameterless method. That is, we're not passing in any parameter to this method. But in the course of this class, we also make use of methods that requires parameters, just for us to see how those ones work. All right. So now we are moving to another key thing in C#, which is constructors. Okay. So I believe we all understand what we've done so far. So this is another key, the key thing for us to understand in C# is called constructors. Okay. A constructor is a special method that is used to initialize.
Sorry, Kennedy.
Okay.
Yeah, so we have 4 minutes left on this call. So I would suggest that we start again so that you can just start constructor from a new call instead of breaking it when this call expires.
Okay.
Yeah, so I'm going to end the call now and then everybody can just join again. I'm going to be starting it almost immediately. I'm ending. So just join again after I end the call.
Okay.